Well, greetings, mathletes, and welcome back. We're going to continue our discussion about inverse trig functions today, and we're going to kick it off with looking at tangent. That's the one that we haven't looked at yet. It's just because tangent's a little bit trickier than sine and cosine. We're going to take a look at the calculator and how to come up with these things on the calculator. And then a little bit, I don't even want to call it an application, but it's one of the places that that inverse trig functions are used. And it's really a geometric application. So it'll give you a little better understanding about what these things are actually doing. I do want to say that we're really not going to have a good sense of how to use these things for anything useful until we apply them to something. And so we're going to be doing that coming up real quick here. Probably the next lecture, we're going to be looking at how to use all the stuff that we've been playing around with to find things out. You know, if you're walking down a road and someone says, "Hey, how tall is that building?" And if you can work out a few measurements, you can actually figure those things out. Not that that happens all the time or anything. You know, you're just walking down the street and figuring out heights of buildings, but you get the idea. It's going to open up a lot of things for us if we can apply these to actual situations. So let's go ahead and get started here. Okay, so now with tangent inverse, we don't have the luxury of having all of our values on a trig wheel. So there's a couple of things we can do here when it comes to tangent and things we already know about tangent. So first of all, we do know some values, right? Just from graphing it, we do know some values that are pretty standard. We know tangent 0 is equal to 0, right? And you can picture that because the point 0, 0 is part of the tangent graph. At pi over 4, I know it has a value of 1, right? Because pi over 4 is where sine is equal to cosine. If you wanted to work that out, you can always just look at the value of tangent of pi over 4 as sine pi over 4 divided by cosine pi over 4. And both sine and cosine pi over 4 are the same value. They're root 2 over 2. Right? Well, I'm dividing a number by itself. That gives us 1. Right? So you can work out tangent this way. It actually works out kind of nice. And then the other important value was that tangent pi over 2 is undefined, right? That's where our asymptote is. Now, there's negative values as well, and one of the things I'm going to use here, and I want to show you how to use, is what's called the odd property. And it's not odd because it's unusual. It's odd as in odd versus even. Both tangent and sine have the odd property. Right? The odd property for any function, not just trig functions, but we use them more with trig functions. A function is odd if I take the negative of some value and when I compute it, the function value is negative, right? It's negative of what it would be if it was positive. And this doesn't look like too much here, but how that ends up playing out with tangent is that if I want tangent of negative pi over 4, what that tells me is I can pull the negative out. This is the same thing as the negative of tangent pi over 4. Right? So I can pull the negative through the function. And it doesn't work like that with every function, but it does work like that with sine, and it works like that with tangent. And so we know tangent pi over 4 is 1, so this answer is now negative 1. Basically what this is saying in terms of the functions is that if I know tangent of something, like pi over 4, is 1, then if I take tangent of the negative of that angle, the answer I get is the negative of the answer, right? And that's just what I did here. So basically what that's saying, just to restate it in a different way, right? We already know it's equal to 1, but really what we're saying is that if tangent pi over 4 is equal to 1, then tangent negative pi over 4 has to be equal to negative 1. So if you want the negative angle, you just make the answer negative, right? And that's basically what it means. And you're doing the same thing with sine. Sine is also an odd function. If I have sine of, oh, I don't know, let's do sine of pi over 3, right? Sine of pi over 3 is negative root 3 over 2. Well, oh, not negative. I'm sorry. I was already thinking ahead to what I was about to ask you guys, right? Sine pi over 3 is root 3 over 2. So that means that sine negative pi over 3 is negative root 3 over 2, right? So if you're taking inverse sine of something that's negative, you're going to get a negative out. If you're taking the inverse sine of something that's positive, you're going to get something positive out. And the same thing with tangent. Okay, so that's the odd property. And what that's going to enable us to do is find the rest of these values here. So let me go ahead and clear some of this off. So we did that, yeah. So we'll do that, and then I'm going to get the odd property off of here. And we'll fill out a little bit more. Okay, so automatically, because tangent pi over 4 is 1, that means that tangent negative pi over 4 is equal to negative 1, right? So we're getting that for free. I don't have to worry about 0 because negative 0 is still 0, and undefined is undefined, right? That's it. If you're undefined, you're undefined. So you don't worry about the signs there. Now, whenever we're talking about inverses and the intuitive feel for them, there is usually the angles pi over 6 and pi over 3 are also included. So let's talk about the tangent of those angles, right? If I have tangent of pi over 6, that's sine of pi over 6 divided by the cosine of pi over 6, right? Well, sine of pi over 6 is 1/2. Cosine pi over 6 is root 3 over 2. Okay, so if I go ahead and do that division, flip and multiply, I end up with 1 over root 3. And if I rationalize the denominator on that, I end up with the square root of 3 over 3. Right? And rationalizing the denominator, just so we're clear on that, I just multiplied the top and bottom by root 3. That's one of the things we covered at the very beginning of the semester. So if you need to go back and look at that video again, go ahead and check out, I think it was the first video we did on simplifying roots and rationalizing denominators and stuff. So you probably want to check that out again if you didn't follow that. Okay, so we get root 3 over 3. So I know now tangent, oops, I want to go back to blue. Tangent pi over 6 then is root 3 over 3, and that gives us tangent negative pi over 6 for free. It's negative root 3 over 3. And then if we look at tangent pi over 3, right, that's sine pi over 3 over cosine pi over 3. And let's see, so that's root 3 over 2 is tangent pi over 3 divided by 1/2 is cosine pi over 3. And if I flip those and multiply, I end up with the square root of 3. And so I'm running out of room real fast here, aren't I? So tangent pi over 3 is equal to root 3. And likewise, tangent negative pi over 3 is negative root 3. Right? So it's a really convenient property. Once you find the positive one, you have the negative one too. Right? And that's the same thing for sine. Cosine doesn't fall into this at all because cosine inverse only spits out angles that run between 0 and pi. Right? So it's only positive angles it spits out. So we don't even play with cosine when it comes to this. Okay, so we have all those two things. And I just want to point out, there's only two things that we added that are actually new, right? Which was computing tangent of pi over 6 and computing tangent of pi over 3. Those are the only new things there. Other than that, we're just kind of looking at the same thing in a different way. Okay. So let's go ahead and actually take a look at some of this here. So if I'm looking for an exact value of something like tangent inverse of the square root of 3, right? Really what I'm looking for is I'm looking for an angle so that tangent of theta is equal to the square root of 3, right? So what I'm trying to find out is what that angle actually is. So we just found out that the square root of 3 is the tangent of pi over 6. So that means inverse tangent of the square root of 3 is pi over 6. So at this point, it just becomes a matter of looking back and figuring out which one it is. And if it happened to ask for the negative root 3, it ends up being the negative angle. So really, you only need to know the positive ones, and then you get the negative ones for free. Okay? Okay, so that is computing exact values of tangent. Okay, there's actually, and don't be fooled, these aren't the only exact values of tangent you can find, but they're the ones that we're going to be dealing with for right now. Okay, so let's go ahead and take a look at the next thing here. Okay, so the next part here has to do with the calculator. So let's go ahead and pull the calculator out here and turn it on. This calculator simulator is funny. Normal calculators are set because they're on batteries, so that if you leave them on, they turn off on their own. This one does the same thing. If you leave it open and on, it will turn off on the timer too, like it has batteries. I think that's hilarious. Let's go ahead and clear this off. There we go. Okay, so computing sine inverse, cosine inverse, and tangent inverse using the calculator. So let's just go ahead and walk through each one of these. First of all, you want to make sure that let's try this again, that your calculator is set to radians. Right? You can deal with this in terms of degrees and stuff as well, but we pretty much deal with radians on this, and that's the only thing we deal with. So what you need to do, you need to start by hitting mode. Okay. Now look here, you see if I go down to the third thing, right, it says radian, and that's degrees. So right now it's in degree mode, and then right now I've just changed it back to radians. And basically you just put the cursor on it and then select. And then once you selected it, the setting is changed, right? You don't have to worry about anything else. All you need to do from there is to clear it, or second function quit, so you can go back to the main thing. So it's already changed. You don't have to hit save or anything like that. So once we have it there, now keep in mind, most calculators are going to give you the radians in decimals, right? So it looks different than a radian answer, but it's still a radian answer. So let's say we want to do sine inverse of 1/2, right? We want to see what sine inverse of 1/2. So we want to know what angle will give us 1/2 when we plug it into sine. So now if you look over here on your calculator, you see the sine button, right? Maybe I can make this bigger. There we go. There's the sine button. It's the second function on the sine. It's that sine to the -1. So we're going to do that. So we want sine inverse. I can either put it in as 1 divided by 2 and then close the parentheses, or I can put it in as 0.5, right? It'll take the decimal or the fraction. And then we hit enter, and it gives 0.52359. How do we know if that's right? Well, one, it is right, but one of the ways you can check, just so you have a better sense of this, if you know what the sine of what angle gives you 1/2, which in this case it's pi over 6, right? We know the answer is pi over 6. So we just need to see if pi divided by 6 gives us the same answer. So let's see. Pi is the second function here. So let's do second function pi divided by 6, and then we hit enter, and we get the exact same number, and that's how you know what it is. You're not going to be able to convert it back to units of pi without knowing them. So decimal answer is fine in these cases, right? And you're going to do the same thing with cosine and tangent, right? Here's what you want to remember, though. Sine inverse of theta will always spit out things that fall between negative pi over 2 and pi over 2, right? And so as a unit circle drawing, all the angles that sine inverse are going to give, oops, that didn't go where I wanted it to, fall into the first and the fourth quadrants, right? So these quadrants right here are where sine inverse spits things out. So those are all the angles from negative pi over 2 up to pi over 2. That is really, really ugly. Let's try this again. Well, let's do this. I'm thinking way too hard on how to draw this picture. Okay. Right? It's this quadrant here, down to here, up to here. Right? So this is from negative pi over 2 to pi over 2. Right? That's where sine lives. Okay. Now cosine, switch my colors back. Cosine inverse of theta gives you answers back that fall between 0 and pi. Right? And what that means, well, I'll just draw it underneath. Right? That means that cosine inverse lives here from 0 to pi. Right? This is 0, this is pi. Right? So that's quadrant 1 and 2. It spits things out of there. And then tangent has the same range as sine. Tangent theta spits things out in, it's not quite the same because you have those undefined, you have those asymptotes there. So it's an open interval this time because we don't include the endpoints. It goes from negative pi over 2 to pi over 2 as well. So that means that tangent, or inverse tangent, also lives in the first and the fourth quadrants, right? From negative pi over 2 to pi over 2. So, and actually that's part of the, well, there's a lot deeper explanation, but the fact that they are both odd functions is why they occupy quadrants 1 and 4, and the fact that cosine happens to be an even function is why it occupies quadrants 1 and 2. So, but more on that later. Okay, so just remember that, and then remember that odd property because that can save you a lot of time. Because sometimes it's hard to figure it out in the fourth quadrant, but it's easy to figure out in the first quadrant. So you do that and then switch the sign, right? So it works a little bit better that way. Okay, so that's plugging it into the calculator. So we'll go ahead and put our calculator away. Let's pull that back out if we need it. All right. Now, the last thing we need to talk about actually is probably the more technical part of this, is how to figure out a very specific type of problem, and that's the composition of a regular trig function and an inverse trig function, right? So here's the for instance, let's say I want to find, and I have some things worked out here. Let's say I want to find the tangent of the inverse cosine of 3/5. Okay, so here's the part where we're lucky. We don't have to find the angle, right? You could go through and take the inverse cosine of 3/5 in your calculator and then take tangent of whatever number you get and then see what comes out of it. You could absolutely do that. But you're not going to get an exact answer. You're going to get a decimal approximation. And a lot of these answers are going to have square roots in them. And you're not going to see that from a decimal answer. So here's what we do. We start by pulling this cosine inverse out. Okay, so cosine inverse has to be equal to an angle. That's what we're looking at, right? Cosine inverse, I'm going to call theta, because why not? I can call it anything I want. I'm going to call it theta for right now, which means that what we're really looking at is tangent theta, right? Because this is now theta. Okay, well, what we can do with this is we can actually draw a picture. Okay, so I know cosine operates in quadrant 1, or cosine inverse does, operates in quadrant 1 and 2, okay? Cosine inverse is negative in quadrant 2, right? The angles, so here's how I'm going to deal with this thing. What I'm going to do, these are both positive numbers. So I can go ahead and think, okay, cosine is the adjacent over the hypotenuse. So that means that this side is 3 and the hypotenuse is 5. This angle here is theta. Okay, now keep in mind, tangent of theta is the opposite over the adjacent side, right? So we need this opposite side. If I had that, I could figure out what tangent of that angle is. Well, I can figure it out with the Pythagorean theorem, right? Remember, if I have a right triangle, well, let's try that again. I don't want to do that just yet. If I have a right triangle with side lengths A and B and hypotenuse C, then the squares of the legs is equal to the square of the hypotenuse, right? That's what the Pythagorean theorem says. And we have a hypotenuse and one of the legs. So that means that 3 squared plus B squared is equal to 5 squared. And so I have 9 plus B squared is 25, which means B squared is 16, and B has to be plus or minus 4. Okay, well, we're in the first quadrant. We're not going to be minus 4, right? So that means it's the positive value, and we'll go from there. So now that we know what this side length is, we can work out what the tangent of that side length is, and it is 4 over 3, the opposite over the adjacent side. Okay, so let me walk back through what I did. Since cosine is the inverse of, or cosine inverse is the inverse of cosine, in fact, I can actually look at this a little more. If I just rewrote this, what this is actually saying is that cosine of theta is equal to 3/5. Now, and we saw those things before when we were like, find the value of all the trig functions if cosine is this in the second quadrant, right? That's why we were looking at these things. It was building us up for inverses. And in any case, so we started by looking at this, and then we figured out which sides these had to be because of the fact that it was cosine. And so we built that triangle. And since we had 2 sides, we could figure out the missing side. And then from there, we could figure out tangent, right? And so, it's kind of interesting. Let's take a look at another one here. Same kind of deal. Oops, that is not what I was trying to do. There we go. That's what I was trying to do. Okay, so let's see here. How about the cosine of tangent inverse of 1? Right, that should be interesting. So yeah, see what you can do with this. And so pause it here and see if you can work that out. And then once you're done working it out or completely stumped, play it again and see what the solution is. So go ahead and pause it here.
Did you pause it?
Okay, so let's take a look. So again, we're going to pull tangent inverse out. And we'll just call it theta. So really what we're looking for is cosine theta. And if tangent inverse of 1 is equal to theta, that means that the tangent of theta is 1. And if the tangent of theta is 1, that's positive. And we know if tangent's giving us a positive angle or a positive value, then the angle's positive also, which puts us in the first quadrant. And we need a value of 1. So I'm just going to sketch a triangle in here, and that's theta. And if we're going to have a value of 1, well, 1 is 1 over 1. So I'm going to say that this is a 1, and I'm going to say that this is a 1. And so this side here, 1 squared plus 1 squared equals, I'll call it h squared since it's the hypotenuse. So that means 2 is equal to h squared, and so h is equal to the square root of 2. Now we have all the sides of the triangle. We can figure out any trig function we want. Cosine theta is going to be the adjacent over the hypotenuse, which is 1 over root 2. And I do want to mention, I know I mentioned it before when we talked about roots and stuff, there's nothing wrong with writing 1 over root 2. But oftentimes it's just easier if we have the root on the top. So we go ahead and rationalize the denominator. And if we do that, just multiply by root 2, I get root 2 over 2. Right? So I just found that cosine of the tangent inverse of 1 is equal to root 2 over 2. Right? So basically what you're doing is you're piecing it together from, you're peeling down the layers of tangent inverse to the 1 and then using that 1 as a ratio to figure out what cosine is. Okay, so let's go ahead and take a look at the next one. And this one should be interesting. So let's see what we got here. So let's say I want to find an expression and they don't say this, but it's a non-trig expression they're looking for. Right? So we want to find a non-trig expression for the following. Well, let's take a look at it here. Where to go? Oh, there we go. Okay, so here's the expression we're going to be dealing with. We want to find the cosine of sine inverse of x. Now, this is a really bizarre thing to look at. But it turns out that when you have something like this, you actually can rewrite this as an algebraic expression in terms of x and no trig functions whatsoever. And it's basically the same thing we just did with numbers. So let's go ahead and look again. We'll go ahead. There's actually one more restriction that's given when you're given a problem like this. And we're told that x falls between 0 and 1. Okay, so x is the argument of sine inverse. And if it's falling between 0 and 1, sine inverse has values of from 0 to 1 in the first quadrant, right? Because that's where the angle starts at 0 and goes up to pi over 2, where sine is 1. So this is telling me I'm in the first quadrant. So x is a positive number. That means I can draw my angle here. Okay, now let's take a look the same way we did last time. If sine inverse of x is equal to theta, right? Because any of the inverse functions are equal to an angle. That means x is equal to sine theta. And remember, sine is opposite over hypotenuse, right? So that means I have an x over 1 So if I call this theta, that means that this side is x and this side is 1, right? Okay, so now we need to figure out an expression for the other side. Well, let's see here. 1 is the hypotenuse, so that means that, let's see, we'll give this side a name. Let's call it A, just because. So we're looking for the value of A in terms of x. So that means that a squared plus x squared is equal to 1 squared, which means that a squared is equal to 1 minus x squared, and a is the square root of 1 minus x squared. So now we have a value to put in here. Right? Now that we have that value to put in here, we can compute any trig function we want. I could find tangent, cotangent, secant, cosecant, sine, cosine, and cosine is what we're after. So let's look at what cosine of this angle would be. Cosine of theta would be the adjacent side over the hypotenuse. And so that means that cosine of sine inverse of x is equal to the square root of 1 minus x squared over 1. And so you don't really need the over 1. Oftentimes it's something else, but, right? And, you could do the same thing with tangent. If I wanted tangent of sine inverse of x, it would be x over the square root of 1 minus x squared. Right? So they get kind of complicated and it becomes an algebraic expression, but the fact that I could take this messy looking thing and say, nah, I don't want to write all that. All that is equal to the square root of 1 minus x squared. And that's an expression that's a lot easier to deal with. And so you turn a geometry problem, oftentimes you end up turning a geometric problem into an algebraic problem. And this is used very heavily in calculus. So I do want to tell you one of the things, and it's a second semester calculus thing to do, but there's something called a trig substitution. And I remember when I was a student having to learn that stuff for the first time, it was very, very difficult for me to wrap my head around. But the fact that you're covering this stuff now will make it a lot easier for you to see those things later on when you actually get to that level. So these things are important. This is the basis for what you would call a trig substitution in calculus. Okay, well, we've pretty much hit everything we need to hit here to wrap up inverses. So our next lecture is going to be some applications. And basically all I'm going to be doing is chucking a bunch of word problems at you and then seeing how to work them out. We're just going to see what we can do. So in any case, until next time, keep your pencils and your wits sharp.